Hello, my name is Mr. Chon. Welcome to my study room. Today we are solving objective questions 4 and 9 of the 2023 WASSCE Further or Elective Mathematics paper written by Ghana. I choose to put these two questions together because they appear to have the same understanding in solving them: indices and logarithms. Let's go straight to the question 4, which reads that given that the square root of 3 or exponent 5x minus 4 equals 9 exponent 2x plus 1, find the value of x. Like I said earlier, this question is indices question, and indices simply requires us to express questions to either have the same basis so that we can equate the exponent and solve for x, or have the same exponent so that we can equate the basis and solve for x. So that is what we're going to do right now. I'll first start by rewriting the same question. Just as I said earlier, the main task ahead of us is for us to express each side of this equation to have the same base so that we can equate the exponent and solve. And here it is easy to express this and this as base 3. So that's what I'm going to do now. If you remember your indices lessons very well, you remember that the square root of a number can be written as the number exponent 1/2. So square root of 3 will be written as 3 exponent 1/2. Then now we attach the 5x minus 4 equal to 9 can also be expressed to the base 3. So 9 becomes 3 squared. Then we remember to multiply 2x plus 1. The parenthesis is very necessary because if you don't bring the parenthesis, the 2 will multiply only the 2x without multiplying the 1, but it's multiplying the whole exponent. So that is very necessary. And now that the bases are the same, we can now equate the exponent, this, and then this, to solve for x. So that's what we're going to be doing. And that will mean that 1/2 multiplying 5x minus 4 will be equal to 2 multiplying 2x plus 1. I don't want to deal with fractions, so I'll multiply both sides by 2. So multiplying both sides by 2, I'm going to have 5x minus 4 to be equal to 4 multiplying 2x plus 1. And then simplifying this further, we're going to have 5x minus 4 equals 4 times 2 is 8, so 8x plus 4 times 1 is 4. And subtracting 5x and 4 from both sides, which is the same as grouping like terms, we are going to have negative 4 minus 4 to be equal to 8x minus 5x. And then negative 8 will be equal to 3x. Dividing both sides by 3, we are going to have x to be equal to negative 8/3. And looking through the options, all the options here are either proper fraction or mixed fraction. So the answer, as you can see here, is option B. But then to verify this, we just put this into our calculator. So let's verify that quickly. We have our calculator and we simply punch negative 8/3. So you bring your negative, make sure you use a negative sign and not the subtraction sign. And then you bring this fraction sign, 8 divided by 3, and then equal to, you have this. Then you go to shift SD, and that gives us negative 2 whole number 2/3. Yeah. For more on how to use the calculator to change common fractions to decimal or mixed fractions, I have videos on that, and I'm sharing the link, which you can check later. You can also find the link in the description box. You can check later just to get more understanding of how to use the calculator when it comes to fractions. We move to the next question, which is question 9. Question 9 reads that given that log y to the base 4/9 equals log 2 to the base 8/27, find the value of y. And this, as we can clearly see, is a question on logarithm. And because calculator is allowed on this test, the easiest option if you don't know how to solve it will be to put this right hand side in your calculator just as it is. You write the answer down and then you plug each of these in place of y until you get an answer that is equal to that. So that is the last option if you don't have any idea on how to solve it. Then we can do the same thing to the question 4 that we solved earlier as well. You can pick each of the values and substitute it in place of x and see which of them will let the left hand side be equal to the right hand side. So you could have done that for the 4 as well. But that one is you are testing, you are doing try and error, which will take time. So you can just go ahead and solve it straightforward if you know how to solve it. But then if you don't know how to solve it, then you have nothing to lose. So for that one, you can just test each of them to see the one that will give you the same answer. But then with this one, because I don't want to do the try and error, I will show you how to solve it. But definitely you can make the try and error your last option if you're not sure what to do. I mean, it's also good if you solve it, you can also use that your answer, substitute it in place of y to see whether the left hand side gives you the same value as the right hand side. It's a way of verifying. So like I said earlier, this is a logarithm, and by solving this, the best approach for us would be to use the change of base idea to solve this. And because we are using change of base and we have 2 here, I will introduce my own base 2 so that it can turn this to 1 later as we move on, if you understand logarithm very well. So using change of base, I will express this left hand side as log y to the base 2 divided by log 4/9 to the base 2. So I just introduce a different base and then express this and this as separate log. So that's what I did. Then that will be equal to log 2 to the base 2 divided by log 8/27 to the base 2. Then solving further, this is going to give us log y to the base 2 divided by log, both the numerator and denominator are perfect squares, so we can break them down as 2/3 square to the base 2. And that will be equal to log to the same base gives us 1. So 1 divided by log, and then this one here to the 8 and 27 are cubes. So this will also be 2/3 exponent 3 to the base 2. And multiplying both sides by this denominator here, we are going to have log y to the base 2 to be equal to, this now become the numerator, log 2/3 all squared to the base 2 divided by log 2/3 all cubed to the base 2. And then one of the reasons why we break this down this way so that they have the same numbers in the parentheses. So solving further using one of the laws of logarithm, this will drop here to come and multiply the log, and this will also drop here to come and multiply the denominator. So let's do that quickly. So log y to the base 2 will be equal to 2 log 2/3 to the base 2 divided by 3 log 2/3 to the base 2. And then this and this cancel out, so we have log y to the base 2 to be equal to 2/3. And then by the definition of logarithm, we are going to have y to be equal to 2 exponent 2/3, which is simply this number going to carry this, or 7 as the base for this. That's what we have here. And then expressing this as the reverse of what we did in question 4, don't worry, I'm going to show that. It can be written as 2 exponent 2 exponent 1/3. And that means y will be equal to, you remember this and what we did in question 4, then that will be the same as cube root for the exponent 1/3 of 2 squared, and then that gives us cube root of 4. And looking at the possible answers here, it means that is option B. And don't forget that if you cannot remember how to do all of this, you can put each of these numbers in place of y. And the equal to sign or the equation means that whatever you get for this left hand side should be equal to whatever you get when you put this one in. And then obviously, if you're able to put this into the calculator well, just the way you see it, you should be fine. This one will be the correct option. And that is where we bring today's lesson to an end. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.